Hey Year 10, this video is going to be about 4J, but before I start talking about the new stuff in 4J, I just want to touch on the unit circle again, just as a bit of a recap, because people can find it a little bit confusing at the start, which is fair enough. Uh, so this is what the unit circle looks like. We've seen that before. It's supposed to have a radius of 1 unit. So from here to here would be 1. So it's pretty much drawn on an axis. Here's our y-axis, here's our x-axis, and I've put a few different points in there that we can see. So it's like the outermost edges, and we can see from here to here is 1 unit, from here to here is 1 unit, etc., etc. I've also put in a few different angles that we're commonly going to see and that we are pretty familiar with. So we'll see over here we've got 1 and 360 degrees, and also we've got 90, 180, 270, etc. Now, unlike a clock, we're used to a clock going around this way, aren't we? So for some people, it can feel a bit weird that the unit circle is supposed to rotate around in that anti-clockwise direction, but that's something you're going to have to get used to, and you will get used to that. Uh, but before I start talking about anything else with it, I just want to mention what it's actually for. So I've got a few things that I want you to know written down here, a few of the key things. That unicircle was created as a simple way to find the side lengths of triangles. Now, it might not seem simple at the moment, but hopefully it becomes that way as we work with it a little bit more. But also, if you look at, it says triangles here. I'm not really seeing any triangles in the circle, am I? So before I go into those other points there, I want to show you what I mean by triangle in the circle. So we might be given a certain angle, or we might be interested in a certain angle. I'm going to choose an easy one to start with, which can be 45 degrees. So I'll draw my 45 degree angle in there, and I'm going to stop when it gets to the circle. Now, I still don't really see a triangle, but you're going to make one. So when your angle line hits the circle, you're going to be able to draw a vertical line that goes down, drops down, and it hits that x-axis there. But also, at the same time, you're going to be able to draw a horizontal line over here. And you'll see that that's made a right angle triangle. Now, these are the triangles that you're talking about. If we had a 60 degree line, which would be up here, your triangle would be a little bit different, wouldn't it? Okay, now, the main sort of things that I wanted you to take from the other lesson was that your sine degrees is the vertical part of the triangle. So sine is this length, and cos is the horizontal part. So cos would be this length. So if you put into your calculator sine 45 degrees, the answer that you're getting is actually the length of this part of the triangle. And also, if you put into your calculator cos 45 degrees, the answer that you're getting is this part of the triangle here. Now, again, if we had 30 degrees, the triangle might be a bit different, would have different lengths. But what you're going to end up seeing is that the triangles from this first quadrant that you find, you're going to be able to see them in other quadrants as well. So that's what I've got written down here. So triangles that you find in the first quadrant, you can find in other quadrants. So for example, this triangle here, I could find one that's really similar over this side. Now this isn't absolutely perfect because I've drawn it by hand, but can you see that those triangles are pretty much the same thing, but they're the mirror image of each other? Now this angle over here would be 135 degrees. Can we see that the cos parts of the triangle, so this bit and this bit, they would be the same, except this part's over on the negative side, which we'll talk about a little bit later. And also the vertical part's the same as well. So this sine bit would be the same as that one. So what I mean by this is the things that we know about the triangles in this quadrant, if we're familiar with them, we can take those things over to other quadrants as well. And it's going to save us a bit of time. I'm going to move over and start doing the new stuff now though. Okay, so here's the new stuff from 4J, and it's called exact values and radians. Firstly, I'll talk about radians though. Now, we're familiar with degrees. We know what 45 degrees is. We know what 90 degrees, 180 degrees, etc. But we're not talking about degrees. We're talking about radians. Now, You might be familiar with different ways to measure length, temperature as well. So if you think about temperature, it can be measured in Celsius, which we'd use, but it can also be measured in Fahrenheit as well. But they're really measuring the same thing, aren't they? They're just using a little bit of a different scale. Same thing with length. So here we use meters, centimeters, etc. In America, they might use feet and yards, but again, they're just measuring length, both of those things. They're just different sort of systems, different scales. So radians are just another unit of measurement for angles, okay, other than degrees. So I've got our unit circle here. I'm going to show you like how they got a radian. So this circle has a radius of 1, doesn't it? Now a radian is actually, you take that 1 unit, but you do it around the edge of the circle there. So 1 radian is actually about 57 degrees or something like that. But you're not off 57 point something. But you're not often going to see decimals when it comes to degrees. You're going to see pi in your answer a whole lot. Now, something I want to show you is that we know how to get from 0 to 180 degrees. But in radians, 180 degrees is pi. So if you go to here, you've gone pi degrees or pi radians or 180 degrees. But if you continue going around, if you finish the circle, that's going to be 2 pi. Okay, but also 0 because that's where we start as well. Now, I just want to think about a couple of these ones, a couple of key ones. So if to get from here, and we go around the circle to here, and that's pi, if I only want to go to 90, that's half of pi, isn't it? So 90 degrees is the same as pi on 2. But let's think about 45 degrees now. 45 degrees is half of 90 degrees, isn't it? So it's going to be half of this. But you can also think about it as, all right, we've got pi, and we can break it up into different kind of sections or different pizza slices if you want. So if I can see here, that would be 1/4 of pi, 2/4 of pi, 3/4 of pi, and 4/4 of pi. 4/4 is a whole, so that's why we've got pi. 2/4 is a half, which is why we've got half there. So this would be 1/4 of pi, and this one would be 3/4 of pi. Okay, now these are some of the key ones that you're going to find, and you're going to be able to find this one here as well. When you get into year 11 and 12, they don't really ask you questions about any angle. They're only going to ask you questions about specific ones. So those angles are 30 degrees, 45 degrees, 60 degrees, 90 degrees, and multiples of those numbers. So we could get 120, 135, etc., all the way around. So all these notches, they're the only ones you're going to be asked for. Okay, but let's not worry about that too much just yet. Let's go down and think about converting between degrees and radians. Now, here's a little diagram that's actually in your book. I think it's reasonably okay to use. But what it's saying is that if you've got a certain measurement in degrees and you want to get it to radians, this is what you need to do to it. So times it by pi on 180. And the same thing, if you have a measurement in radians and you want to get it to degrees, you times it by that there. So let's use that and try and do it a couple of times. So we want to convert 45 degrees to radians. So we want to go from degrees to radians. So that's what we need to do. So I'm going to do 45 times pi on 180. And that's going to give me 45 pi on 180. But I think we can simplify this fraction. Okay, so 4 of 445s can go into 180, so it's going to be pi on 4. And that's one of the ones that we looked at up the top before as well. So let's see this one. Now we're converting this to degrees, so this is in radians. Often you're going to see, and almost all the time, you're going to see that if it's in radians, it has a pi in there. Okay, so we're going from radians to degrees. So 5 pi on 6 times 180 on pi. So hopefully we can remember how to multiply fractions. This is going to be 900 pi divided by 6 pi. Okay, now we can see here that we can cancel those pi's out. And then if we divide 900 by 6, it gives us 150. So that's going to be 150 degrees. Now, I'm going to move down here for a second. Now, this table here is going to be really, really important for you guys into the future. And it might seem really funny because you've got all these new numbers, and we've got square roots in here, we've got pi's in here and stuff like that. So if you look at it right now and you're a little bit confused, a little bit overwhelmed, that's fine. Don't worry about it. That's totally understandable. But you are going to get used to it. And once you understand the patterns, you're going to know most of these, or pretty much all these off the top of your head. With this table that I've drawn right here, though, it's missing something, which is tan. You'd normally have a tan row down here, giving you the exact values for tan. But we're not going to worry about that just yet because we're just focusing on sine and cos in our triangle. Okay, now what this is saying here is that, well, this row here is in our angle in degrees. So we've got 0 degrees, 30 degrees, 45 degrees, etc. Here is our angle in radians. So 0 radians, pi and 6 radians, which is the same as 30 degrees, pi and 4 radians, which is the same as 45 degrees. And then it has our exact values. Now, what I mean by exact values is the sine and cos lengths of the triangle. So sine would be your vertical part, cos would be your horizontal part. Okay, so what this is saying is that if you have a 30 degree angle, or triangle with a 30 degree angle, the vertical part is going to be, or have a length of 1/2, and the horizontal part is going to have a length of √3/2. So if I go to this one again, if I have a triangle that has a 45 degree angle, the horizontal length of that triangle is going to be √2/2, and the vertical, and the horizontal length of that triangle is going to be √2/2 as well. That's what this whole thing means. Okay, so hopefully that's helped. I'm going to get you to start having a look at the questions, and I'll be ready to help you if you need it.